Hello students, welcome back to our discussion of Chapter 8, Hypothesis Testing. We just went through the various formats of hypothesis test, showed you the key words that were part of determining which format to use. Just wanted to emphasize again that the two-tailed test is the only form, or includes the only form where there's an equal sign in the null hypotheses, whereas other forms have the less than, greater than signs in the hypotheses and null hypotheses. So those are one-tailed tests. The third step we need to do is determine if the test is one-tailed or two-tailed. So of course this is done by using the key words. So a two-tailed test is always going to be have the keywords of different, not equal, might even have equal in terms of the null hypotheses, whereas that's for a two-tailed test. For a one-tailed test, words like greater than, less than, more, at least. So you want to be looking for those words. That'll tell you if it's a one-tailed test or a two-tailed test. So what we can do is go back to our question, and we have words like this. We have different. We have in the null hypothesis statement that the claim is, or are, French fries are 8 centimeters in length. So that implies equality. So this is a two-tailed test. We can also tell, because of the equality sign, that the average is equal to, and the alternate hypothesis that the average is less, or the average is not equal to. So the fourth step of to conduct an hypothesis test is to find the critical value. Critical value is one of those Z or T values. Now Z if we know the population standard deviation, and T if we don't know it, and thence have to use the sample standard deviation. So once again, for T values, remember degrees of freedom equals n minus 1. And this second and third bullet points here, these are important. A two-tailed test, we have to divide alpha by 2. Alpha is always given as part of the question. So alpha is always given in the question. If it's one-tailed test, we can leave it. Or we can just remember to always divide alpha by the number of ends of the distribution, or the number of tails for the hypothesis test. So a two-tailed test, we divide alpha by 2. One-tailed test, we can divide by 1. Or we can just leave it. So if it's a two-tailed test, the critical value will both be negative and positive. If it's a one-tailed test, it will either be negative or positive. And there's some ways we can learn to understand if when it's going to be negative or positive. So to find a critical value, we're always going to use the t-distribution chart, even if it's for a z value. And one thing we may remember from Chapter 7 is that t-distribution chart. Let's go back out here. Let's find this one. That should open for us. Perfect. It works. So this is the t-distribution chart. I've just put it on this screen. And I want to just move it up a little bit. Because remember that the last row, so this is the t-distribution table that we talked about in Chapter 7. We're going to be using that again in Chapter 8. The last row are Z values. So remember that. The top values here refer to a certain alpha value. So in the example with McDonald's, we are the fourth step is to find the critical value. To find the critical value, we know that it's a Z value because the population standard deviation is known. Population standard deviation is known. So basically that is telling us that we can use a Z value. We also have to know what the chance of error is, or alpha. Alpha is 5%. We also have to know if it's a one-tailed or two-tailed test. In the first example we're working on with McDonald's, it is a two-tailed test. That means we divide alpha by 2 to find that correct column we need to work in. So this is the column. So right in here, this column, that middle column, is going to give us the correct Z value. The correct Z value then is found right at the bottom. So that's why we can use the T distribution table to find Z value. Now if, so our Z value will abbreviate, it's always abbreviated alpha, is plus or minus 1.96. And let's just divide that by 2. So that's why we know alpha is 5%. We divided it by 2 to find the correct Z value. So this is that critical value. Sometimes we can just refer to it as a threshold value. It's a key value that's going to differentiate our final decision. So we can go back to our McDonald's example. There we go. Let's draw out this normal distribution. McDonald's claims that the average is 8 centimeters. It's a two-tailed test, so we're going to be, McDonald's is going to be wrong if it's somewhere up here, if our sample average is somewhere up there or somewhere down in this region over here. This region has a critical value of plus 1.96, and down here the critical value negative 1.96. So that's why it's a threshold value or a critical value. If we find that our sample data is somewhere in this area, we know something is wrong. Or if it's something way down here, we know something is wrong. But any value in the middle here where it's not shaded in, we just don't have enough evidence to say that McDonald's is wrong. So that's step 4. Let's put a value over here. The critical value, step 4, plus or minus 1.96. So step 1, find the null hypothesis. Step 2, the critical value. Step 3, tell me if it's a one-tailed or two-tailed test. Step 4 is to find the critical value. Now we can go on to step 6 or step 5. By calculating a certain test statistic. Now the test statistic is going to be a Z value or a T value depending on if the population standard deviation is known. So in this case, population standard deviation is right there. In this case, we don't know the population standard deviation, so we use the sample standard deviation. And this third one is the test statistic when we're dealing with proportions. So both of all three of these are on the formula sheet. You have to determine which one you're going to be using. Because this question deals with the average, we know it's going to be one of these two. And because population standard deviation is known, we know we're going to be using this formula here. So let's go back and calculate. Step 5. Remember, hypothesis testing always has 2 Z values or 2 T values, depending on if the population standard deviation is known. So in this case, population standard deviation is known. We're using a Z value. We are calculating the test statistic, which uses that formula. So the sample mean, X bar, we found the sample average to be 6.8 centimeters. The population average, assumed to be true value, is 8 centimeters. Population standard deviation, 2.43 centimeters, divided by the square root of our sample size, divided by 113. That's how many French fries we counted. So the test statistic, the one we calculate, turns out to be negative 5.25. That's a really big Z value. Usually Z values are between plus and minus 3, or negative 3 to plus 3, somewhere in that range. But negative 5.25, if we put this value on this normal distribution, so we put this up here, negative 5.25 is going to go, let's extend this a little bit. Negative 5.25 is going to be way out there. Oops, let's make that blue. So the sample mean equals negative 5.25. Clearly, it's in this red zone. This red zone is going to extend all the way forever, above, below, and above there. So now, 5 steps done. Remember, there's two Z values. One we find, this one we find on the t-distribution chart, and this one we calculate. So on the exam and the quizzes, that's how I'll specify. Find the critical value. So you know you don't have to calculate anything other than the column by using alpha. And the other one, we calculate the Z value, so you look for your formula. Step 6, let's put this over here in green, is making a decision. Let's go to the PowerPoint for our last step. Oops. State your decision. The decision rule. We will reject the null hypotheses the company claim if the test statistic, the one you calculate, is greater than the critical value. So in this case, reject the null hypotheses if Z is greater than Z alpha, or if we're using t values, t is greater than t alpha. So as we have a little star there, for simplicity, we treat both values as positives when making our final decision. We treat both Z values or t values as positive because it's always easier to compare positive numbers. So to reject the null hypotheses means that we have sufficient evidence, a good enough sample evidence to refute the null hypotheses. If the null hypothesis cannot be rejected, we have failed to reject the null hypotheses. So your decision will be to do not reject the null hypotheses, or it means the same as fail to reject the null hypotheses, or it will be to reject the null hypotheses. So your decision is either going to be two decisions, two and only two: reject the null hypotheses or do not reject the null hypotheses. Never state that. So let's go back to our question. Our decision is going to be reject the null hypotheses if the test statistic is greater than the critical value. The test statistic is 5.25. Even though it's negative, we're going to keep it as a positive to make our decision. And that's far greater than 1.96, that threshold or critical value. So we are going to reject the null hypotheses. We can also make that decision because it's so far in this red area. So that's our 6-step process.